Okay, so we are going to be learning about division of polynomials, and there are two types of divisions of polynomials, one of which is called long division. Now, here's the thing. In order to be able to do long division with polynomials, we have to remember how to do long division with numbers. And I know a lot of you haven't even thought about long division with numbers in a while. So I wanted to go through a couple of examples with long division with numbers to make sure you remember the algorithm, meaning the steps that you follow to make it happen. So when we start doing the long division with polynomials, it's not something totally foreign and weird. All right, so here's the long division algorithm. The first thing is you take the numbers on the outside and you divide it into the first number that's on the inside. So 8 cannot go into 1. So if it can't go into that, then you add another number to the thing. So you're just figuring out how many times 8 goes into 13. So the first thing you do is you divide 8 into 13. So if you can get 8 into 13 one time. So I'm going to write a 1 up on top. The second thing you do is you take that number you just wrote up on top and you multiply it by the thing you're dividing by. That's called the divisor. So we're going to divide, we're going to multiply 1 times 8, and that goes underneath. Then we're going to subtract. We're going to subtract that 8 from the 13 that it's up under, and that will give me 5. And then we're going to bring down the next number. So we'll bring down the 7. And then we repeat these 4 steps again. 8 goes into 57, and that goes in there 7 times. Multiply 7 times 8, that's 56. Subtract 57 from 56, sorry, 56 from 57, that gives you 1. And then bring down your 2. Repeat again. 8 goes into 12, 1 time. Multiply 1 times 8, put it underneath. Subtract 12 minus 8, and we get a 4. Now, when you were learning about this stuff in 3rd, 4th, or 5th grade, there are 3 different ways you could deal with that remainder. One was to write 171R4, meaning remainder of 4. Another would be to add a decimal and then start adding zeros so you can keep going with the numbers that are there. But the way that we're going to do it with polynomials, so I want to actually sort of emphasize this with you, is to write your answer as a mixed number. So that would be 171, that's the whole part. And then you take your remainder and put it over your divisor, and that gets added to your quotient, which is the answer. So that would end up being, as a mixed number, 171 and 1/2. So let's do this second one together, and I'll do it quickly without going through all the steps. 14 to 37 twice. 28, 2 times 20, 14 is 28. 37 minus 28, 9. Bring down the 5. 14 goes into 95 6 times. 6 times 14 is 84. Subtract those, that gives you 11. Bring down the 3. I believe 14 will go into that 8 times. 8 times that is 112. Bring down the 1. 14 goes into 11 0 times. So we're done because we don't have anything to 0 times, well, 0 times 14, we'll go ahead and do it, is 0. Subtract 11 minus 0. And my remainder, I don't have anything else to bring down, is 11. So my answer here will be 2,680 and 11/14. Now I'd like you to pause the video and do this last problem, and then you can unpause the video and check your answer. So here's the answer to that last problem, and you may have run into something a little bit interesting in this last problem that happens to us when we're dealing with polynomials. See right here, it subtracted away, left me with 0, and I brought down this next 7. When I tried to bring 12 into 7, it wouldn't go in there any times. So I had to put a 0 there, and then 0 times 12 gave me this. And so I kept going with the process. So if I can't go into it evenly, you go ahead and put a 0 down there, and then do the multiplication and bring down the next thing. So you'll see how this works with polynomials when we do it together.